Okay, so today we're going to talk about MongoDB. It's not going to be a typical MongoDB introduction, I suppose. It's just a little bit around what it is and a little example and then some other stuff. Okay, so what is MongoDB? Well, MongoDB is an open source database and stores data in a JSON-like document that can vary in structure. It is defined as a NoSQL database, which means not only SQL. There are lots of different types of NoSQL databases. So document document-oriented database like MongoDB, for example, or a document store, or a wide column store such as Bigtable, which is used at Google, or Cassandra, which is used by Facebook for messaging. We've got key value. We've got graph, which I'll talk about in a little bit, and multi-model. But there is some overlap between those. So those aren't great. You can't really sort of pigeonhole them all because there is some sort of overlap in there. Over the last few years, especially with the growth in social media and also online presence in general, new databases have been created that meet a particular purpose well. So, for example, think of trying to build Facebook and simply finding friends of friends of friends on a simple MySQL table that connects 5 million users, where each user has on average 50 friends. Now, if you think about this, doing a simple select statement means, and to get the information about those, even just a friend, would mean going through of the possible, um, all of the possible roles that you could think of. I mean, I'm just thinking in my head. Sorry, I'm going to stray off my script, as it were. What if it's to do with where you work, for example, or to do with who is your friend? When it's giving you suggestions, the kind of thing I mean, like friends of friends or people you might know because it somehow found something from your email address, or something that you've liked, those sort of things. Just think about how difficult that would be. So MySQL is actually used by Facebook. So I hate when I start off by saying this, but it is actually used by Facebook. But it's part of a layer. It's part of a set of layers called Tau, their database system called Tau. And MySQL has actually got better over time because their developers have constructed things like better use of memcache, which again I'm not going to go into today, but just letting you know. However, the graph layer of the database is what's important to what I'm discussing here. So they built a graph layer because doing a select on those 5 million users, if you were to do friends of friends of friends or something else like that, would take an awfully long time to do. And in fact, in the module that I teach in the honours year, we used to do that and it took a very long time to be able to do it. Such to the students' dismay, we don't do it anymore. But by having a graph database means we can use a different type of algebra or math to be able to get from one node to the next rather than using a table. So it turns out that using tables isn't the best way to create something like Facebook. Okay, so we use those types of database, use different types of database for different things. So, the graph database gives a speedy response to that type of query. However, they have a separate database called Cassandra for their messaging system. Because if you think how many messages are sent per day and how many users are all interconnected, no matter how often you log on to Facebook, your first message is instantly there from all your users, from all your friends. They're instantly there. And Cassandra was designed specifically for that purpose. So you should note that when I tell you about, using MongoDB or using MySQL, it actually depends on what you need it for. So I know I was part of a big project down south, and they have three different types of databases for the same application, the same web application, because lots of different databases do different things. Anyway, that's off track, but it's just to let you know that those things do exist. And, they can be used for different reasons. I often liken using something like MongoDB for standard applications as using a jumbo jet to get to your work when you live, in Perth. It's a bit silly, really, because a car does the job much better. Anyway, so MongoDB is designed to be scalable. Evidently, some of its users can show that quite simply. So Google, for example, HMRC, Royal Bank of Scotland, Cisco, Expedia, EA, and eBay, and things like that. And it has big data in mind. And also the dynamic schema that it has. So the dynamic schema means that you don't have to, or typically when you were designing a database with Jill this year and before, um, you've had to create the database, design it and everything, and do the normalization, and then when you make a mistake, then you have to go through that process again. Or say you don't make a mistake, but later on something happens, and you want to be able to add something in. It could be anything like a variable. You just add a variable in, maybe not a variable, but a field in that does something like a boolean that does something important. And then you have to go and design the whole thing again. It becomes a pain, especially if that's important to the structure. I mean, sometimes it might not be, but if it's important to the structure, still you've gone through that process. So the dynamic schema that we have means that we don't have to do that over and over again. We can simply just add in a new key value pair or a new field, and it'll just seamlessly work. So, they can have different objects, have different things in them. You don't have to have a null in there, or you don't have to handle that and, add a blank in. You know how sometimes if you put middle name and someone doesn't have a middle name, then what do you do with that? If you make it a null and you're expecting a string, then a problem happens, as you know. So, you don't even have to deal with that. It just doesn't exist, right? So, and also you don't want to take up space. That's not a big problem anymore, but anyway. So it just seamlessly works. And also high availability. So high availability databases use an architecture that's designed to continue to function normally, even when there are hardware or network failures within the system. So like we talk about Facebook, a billion users or whatever. I can't even remember how many users there are, but there's a lot. And they're not all obviously in, in close proximity to you. They're all over the world, right? But every time they log on, regardless of which network has gone down, generally speaking, virtually all the time it will be up somewhere based on the architecture. And Cassandra is eventually consistent, for example. As I mentioned, Cassandra is a database system. It's eventually consistent among all databases as a replica. But the fact is that, it's designed to be like that. So it continues to function normally, even when there are hardware or network failures within the system. Now, these have emerged as an alternative to traditional relational databases because those are generally built to be deployed on a single server, and they rely on some sort of master replica architecture to provide availability. So I know this as well as anybody with the thing we build just now. Well, not right now because we're using MongoDB for that, but the old one is that when something goes down, we just boot up another server. And we need to make sure that we have updates and we can pass the data in to make it sort of seamless so we lose as little as possible. But that becomes a bit of a pain and it's not quite as available as good as these systems for when they go down. So yeah, I mean, I'm hoping that you all know what MySQL is. You've been using it, pretty much all the way through. What else can I say about MongoDB before we move on? Okay, so I could say we know that it's JSON-like documents, as I mentioned before, and it can vary in structure, but the related information is stored together for fast query access to the MongoDB query language. Now, MongoDB uses dynamic schemas, as I said before, so that means that you can create records without first defining the structure, such as the fields or the types of the values. Now, actually, in practice, it doesn't really work like that, especially if you create an API. You do have to have a schema. However, that's a different story altogether. Anyway, you can change the structure of the records, which are called documents, and you can do this simply by adding new fields or deleting existing ones. And this model gives you the ability to represent hierarchical relationships, so to store arrays and other more complex structures easily. So sometimes in databases that's actually quite tough to do in MySQL, for example. So documents in a collection need not have an identical set of fields, and denormalization of the data, you know, you would say that that's common in MySQL. And like I was mentioning earlier about, the big data in mind, it does include things like, I'll go into this later, but it does include things like out of the box replication and auto sharding. I've mentioned replication before, you might have had sharding. Anyway, so before we move on, or maybe we should, let's hold on a minute and move on a bit. Oops, sorry. Let's talk about JSON and JSON-like. Now, JSON stands for JavaScript Object Notation. Now, you might have seen it, you might not. I'm going to show you a little example in a minute. But the fact is that, well, if you've ever used something like Facebook before and you want to access information from it, then the kind of thing we get back from the graph is usually JSON. And I'll show you what I mean. So let me just show you what I mean here. This is graph.facebook.com and some sort of ID, as you can see here, I think. And this is the ID. And I was looking just to see if I could access something that was open. Now, this here is directly using the API. So obviously this would give us an error back. So if we decided to use some sort of post or get, I think get's probably in this case, a get request, and we would get this information back again and do something with it. This is JSON. And as you can see here, it's net. We have an object. We have the start and close of an object, and then we have our error, which is our key, and our value in this case is another object which has a bunch of key value pairs. So in this case, we've got message, and an access token is required to request this resource, and type OAuth exception, so we can't access things without authentication. And it gives us a code. So if we know the codes, we can obviously create this a really cool interface with it. Um, and obviously, there's we can use Facebook directly um, to create a nice interface or to create something directly linked to the Facebook graph. So when you do web programming with me next year, we will we'll actually do a bespoke login we'll do a bespoke login via the Facebook graph. We'll get this information back about yourself and use that information and store it into a database and everything like that. Anyway, so that's the API, and that's obviously some JSON that's been passed back again, and we'll go and have a look at the presentation. Okay, so as you can see from that, because I was able to read it out, well, it's lightweight obviously, it's not a lot, and that's really useful for when you're passing between networks. It's also easy for humans to read and write. I'm just going to hit this thing over here. Anyway, easy for humans to read and write. As you can see, I read it out. You could probably see everything that was there, so you can see what error, you can see the message, you can see the code that was passed back. It's easy for machines to parse and generate. Well, obviously, I mean, if you've ever used JSON before, then it's quite straightforward to use. You can traverse it quite easily. You can just put in, you want a key and you get a value back, especially in JavaScript, it's pretty easy. Text format that is completely language independent. So when I use JSON, so just now I build a large API. It's an enormous API that's going to be used by an Android application, an iOS application. It's going to be used by a web interface, and it could be used by anything else. So we can actually have other things interface into it if we wanted to, but those are the three main things we're going to do. So it being completely language independent means we're just passing that data back and forward, and I can just use that data the same way. So JSON parsing, it has that sort of defined structure. Now, I said it was JSON-like, didn't I? So let's move on with that. Oops, let's move on with that. Okay, so a JSON structure, it's got an object with key value pairs, as you saw, an array. You can have an array, or you can have some mixture of them. So as you saw, we had a key and a value pair where the key was an error and the value was another object, and that could be an array if you want, or it could be an array of objects. It could be an array inside an object. Anyway, as we'll see down below. So we've got JSON. You've got different data types that you've got with JSON, so string, number, object, array, true, false, and null. And here's an example down here, but forget these quotes, it's just PowerPoint doing that. So we've got name, Russell, title, doctor, age 25, I wish, and known associates. We have an array, so we have Derek, Gillian, and Ian. Yeah, so that's a simple example of what JavaScript object notation is. Now, MongoDB uses a JSON-like format, and it's called BSON, it's binary JSON. It supports the embedding of documents and arrays within other documents and arrays. You saw just a minute ago I spoke about JSON. It's pretty much exactly the same sort of setup. It also, however, contains extensions that allow representations of data types that are not part of the JSON spec. You can go and have a look at them if you want. But date type is an example of that. And also it has its own sort of IDs and things. Again, it's easy for machines to parse and generate, which is useful. And again, it's text format that is completely language independent. So like I said, we could do it with Swift for iOS or Objective-C for iOS. We could do it for Java. We could have it for JavaScript. You could do it with Python, sorry. You could do it with Android, obviously, with it being Java, and so on. Okay. So characteristics of BSON, well, I mentioned some of these things before with JSON, the same applies. So we've got lightweight, so it's keeping spatial overhead to a minimum. Especially, it's important, especially when it's over the network. Traversable, it's easily traversed, as I say. If we put if we created some sort of object, so we pulled something back and called it data, then we had in the Facebook example, if I had data open brackets error and then returned that back again, I would get the nested object from the key value pair. And also it's very efficient because the encoding data to BSON and decoding it is very quick in most languages because it uses C data types. Okay, and I can attest to that. So the basic concepts of MongoDB. Now I mentioned a couple of these things. So the documents is a basic unit of data for MongoDB and is roughly equivalent to a row in a relational database management system, but it's much more expressive as you've seen. Collections is like a table with a dynamic schema. A single instance of MongoDB can host multiple independent databases, each of which have its own collections. This isn't really big news because MySQL can do that, but if you're using Postgres, you get one option. And MongoDB comes with a JS shell for admin and data manipulation, because and that's really quite useful, especially if you know JavaScript, I think. So we'll have a look at an example in just a moment. Okay, so let's just have a quick look at an example. I've got everything installed, obviously, but if I go into the shell, we could do a bunch of things. So this is the MongoDB shell. So let's just create one. It's called use Russell test. Okay, so it's created a database, but there's nothing in there yet. So we can check anyway and see what we're on. So we're on Russell test. If we were to show those DBs, so if we were to show DBs, nothing would show because we've not put anything in it yet. We can obviously drop that database, so db dot drop database. I don't really want to drop the database, but we'll do it anyway. Now let's create a new one. Let's use Russell test. Okay, so we've got Russell test. We can create a collection, so db dot create collection, and we'll give it a name. Russell collection, Russell call will be fine. Create that. Yeah, as you can see, it looks a bit like JavaScript and everything about it. So we've created a collection, and we could do it with some options and things like that, but this is just to give you an idea of what you can do. You can drop your collection as well fairly easily, so you would do db dot russell call dot drop, but again, I don't want to do that, so you would do this, but it doesn't matter, let's do it anyway. So let's create a new one, create a new collection called Russell Call. Now we can also insert into here, so this is where it gets a bit easy. So db Russell Call dot insert. Now we want to, add something useful. So title, let's say it's for a blogging site or something. DB row or advanced databases. Let's say we've got a description. Awesome MySQL. Who's it going to be by? None other than Jill Douglas. We can give it a URL, www.uhi.ac.uk. We can give it some tags so that people know where to find it. So MySQL, SQL, UHI, and why not? You know what? Let's say it's for a blog post. Jill's created a blog post. There's 30 likes. Why not? That's how many of you are going to be here. If we press this, then what have we missed? Have we missed something? What have we missed? I hate when this happens. Oh, of course. Of course. Can you see what we've missed? Always happens when I do this. I'm not taking this out though. What have we done? Oh God, colon is missing. Missed lots this time, haven't I? Anyway, doesn't matter. There we go. So we've written that one, and that's fine. Now I could have put multiple in there. So I could do db dot russell call dot insert. Now if I want to do this, I can put an array, and then I can create a bunch of objects like title test one. Now, I'm not going to write lots of other stuff. This is just going to be this one, and then I'm going to put a comma in here, title test 2. Oops. Now I think if I do this, well, we'll do one more, then that, and then bam. Yeah, so we've got 2 inserted, and that's fine, right? So yeah, pretty good. What do you think? Now let's just see if we could find something. Now there's a bunch of different things we can do. I can't go into it today. I want you to have a look if you want to have a look. Dot find. Let's just find every object inside there. There you go. So we've got our main object. You can see it's added an ID. That ID has a particular purpose. And as you can see there, you see that I've added it into the same collection. I've called it Russell Call. Now what if I called that blog posts? You can see that these tables, I've just created them, and they don't hold a strict, they don't have anything strict there. There's no nulls or anything, there's just nothing. This one here's only got a title, and a title obviously the IDs, and this one here's got lots of stuff. What if I started with these just to see if it was working? Then I thought, well, what will I need? And then what after that? What if I want to have these tags as something else? What if I want to link to another blog post? Can I just put, can I set it up to an ID? Or would I just nest another object inside there? Anyway, you can do lots of different finds and stuff. You can do lots of different things with it. But nothing spectacular today. I want you to go and have a look. I want you to enjoy yourself doing it, and that's fine. So where are we now? Okay, well, MySQL versus MongoDB. Well, there's a bunch of different things that that MySQL doesn't have and MongoDB has, and how fantastic is that? So a rich data model, as we've already seen, dynamic schema, tight data, well, they both got that. Data locality, field updates, easy for programmers, complex transactions. Yeah, it's easier in MySQL for complex transactions without a doubt. And like I say, there are reasons why SQL is still the way to go with many things. Auditing, auto sharding, so you can have a look at shards. There's no point telling you about distributed databases and perhaps the different ways in which you can shard your data to improve um, performance today. That's for a different time, I'm sure. Let's see. I can't remember if this is the end here. I'm going to try and see if this is the end. Yes, it is. So I guess I've got to do all my talking inside here. Um, okay. So why would I use MongoDB instead of MySQL? Oops. Why would I do that? Well, I chose it. One, because I wanted to see what it did, but knowing full well that things were going to need to get very scalable. So the application I'm building is hoping to have a great number of, well, let me just put it this way. If you normally deal with a single server and we're using that kind of data anyway and passing that information in a data-driven form, it seemed like the perfect choice in terms of scalability. Because just now, the application that we built before, I wouldn't say it's particularly scalable, and it needs quite a bit of work in order to improve performance on it, where you have to do a lot of deep level calculations in the database. But anyway, why would somebody else? Why would you use it? Well, I mean, lots of different places of all different sizes adopt MongoDB because it enables them to build applications faster, handle highly diverse data types. So like geospatial, for example, I know that MySQL keeps on growing and things like that, but you know, some of this will still hold true, some of it won't. But anyway, you can also manage your applications more efficiently at scale, as I say, so it's dealt for scalability. Also, the development is simplified as MongoDB documents map naturally to modern object-oriented programming languages. So here's a good example for you. In Derek's class for Java, if you did Derek's class with Java, when you were using you were making a link to a database and you got some information back and you wanted to make some changes to an object, you defined objects, which are called POJOs in your case. These are just the Java objects that you create, so plain old Java objects. And you had to map to them by getting the information from the database, checking what type it is, blah, 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 sticking it in. And we call that an object relational mapping layer. So you're mapping to that object. However, if you were to do a toString on that data, if you had a toString method in one of your objects and you pulled it out, it would look virtually exactly the same as JSON or BSON. So these things already map directly to these objects, so there's no need to have these mapping layers that you would normally have with relational tables. So it's very good for that. Also, MongoDB's flexible data model also means that your database schema can evolve with the business requirements, as I mentioned before. So the weather channel schema changes that took days or weeks with a MySQL database could be made in just hours with MongoDB. This is the example they give on their site. I've mentioned it before as well. And MongoDB can also be scaled within and across multiple distributed data centers, providing new levels of availability and scalability previously unachievable with relational databases like MySQL. So as your deployments grow in terms of data volume and throughput, MongoDB scales easily with no downtime and without changing your application. So in contrast, to achieve scale with MySQL often requires significant custom engineering work, as I mentioned before, and that really is true. I've had to do this. Their example is Badoo, migrated from MySQL to MongoDB to support its rapidly growing business, and the Chinese internet services giant now powers over 100 apps and manages in excess of 1 petabyte of data with its MongoDB cluster. So, lots to think about there. I mean, there are lots of cool cases where you can use MySQL and MongoDB together and stuff like that. And there are lots of bad things to do with MongoDB, but hopefully this is just giving you some sort of insight into what they do or what it does. I encourage you to go away and give it a try. I'm sorry if this has been a bit sort of hodgepodge together. It's just trying to give you a quick overview on what you need to know about it at this point.